So yesterday we were talking about the difference between growth and decay, right? And we looked at equations and we looked at word problems. Today we're going to look at equations and word problems, but we're going to write equations and make interpretations of those equations. You ready? I know. I like big words. All right.
You have like a dangling piece of gum.
Oh, that's gross.
I'll get it in a little bit. So, example 1 says, the function g of x is equal to 257 times 1.25 to the x power represents the number of bacteria in a petri dish where x is the number of hours since the experiment started. All right. So part A says, what is the y-intercept for this function and what does it mean for this problem?
Would you do
Well, we could do a graph, but we don't have to. Remember yesterday in our notes, we said that the y-intercept was the A value, that 257. So my y-intercept is going to be 0, 257. And that means that we start with 257 bacteria. That's the beginning amount. So B says, what are the A and B values of this function, and what do they mean in this problem? So my A value was 257, right? And we said that's how much we start with, right? So we're going to put starting amounts. Please turn the phone off. Or at least turn it down. Thank you. What was the B amount in this problem? 1.25. So what does that 1.25 tell me? We're increasing, right? Because, Darian, it's increasing because, look, is that more or less than 1? More. So that's our growth rate. When I say that's the growth rate. So C says, according to this model, so our model is this equation right here. Predict the number of bacteria after 24 hours. So what we're going to do is I'm going to replace the x because x is the number of hours since we started the experiment, right? So I'm going to replace that x with 24. So it's going to be 257 times 1.25. I'm going to replace x with 24. All right, so can y'all help me with that? What is that? So I'm gonna use your calculator. What's 257 times 1.25 to the 24th power?
I got 100. 5, 4, 4, 2, 1. Oh, wait, that's what I got.
Say it again.
5, 4, 4, 2, 1.9.
So 54,421.9 bacteria. Well, we probably could round that up to 22, right? What do y'all think?
Yeah.
Not so bad? I heard eh. All right. So a note. We don't always get our growth and decay rate as numbers. sometimes the growth and decay rate is given as a percent. So here, remember, when you have a percent, first of all, what do you do to a number that's a percent to change it from a percent to a number you can use? Move the decimal. So for example, what if I said, I don't know, 17%. Let me change here to a different color. 17%. What do I do to that 17? Put the decimal and move it 2 times. 0.17. So what we're going to do, so if you have growth, if I have growth, that's going to be bigger than 1, right? So when we have growth, I'm going to say 1 plus that percent. That percent we just found was the 0.17, right? So I'm going to use that as my example, 0.17. So then my growth rate is going to be 1 plus 0.17, so that's going to be 1.17 would be my growth rate. I just made it up as an example. So for example, if we were talking about 17%. All right. What about decay, though? Decay's got to be less than 1, right?
Minus.
So we're going to subtract. You got it. So here we're going to say 1 minus our percent. So again, we changed that 17% to 0.17 so that it's a decimal we can use. So 0.17, so 1 minus 0.17. What's 1? No, it's not a negative. What's 1 minus 0.17? 0.83? And that's less than 1, right? So that's a decay. Is that okay? Robin looks skeptical. You're a little skeptical too. It's okay. All right, let's do a couple more examples. Let's take a look at the back. On the back, we're going to look at some word problems. I see a few pencils still moving, so I want to wait just a moment. All right. So on the back, we've got example 2 says, there we go. Since 2005, the amount of money spent at restaurants in the United States has increased by about 7% each year. So we have that percent again, right? All right, it says in 2005, about $360 billion was spent at restaurants. That's a lot, right? Billion. So first, let's identify the A and the B value here. So A, how much money did we start spending as a country in 2005 in restaurants?
7%.
Nope. Money.
360 billion.
360 billion. So my B value is 7%, but it says we're increasing by 7%. So what we have to do is we have to make that a number bigger than 1, right?
Mm-hmm.
So first of all, we're going to change that 7% to a decimal. Come on, there we go. So it's going to be 0.07. So what do we do to that 0.07? We have to add it to 1. So 1 plus 0.07. Sorry, my pen's wanting to skip. There we go. So what is that?
1.07.
Perfect. So my B value is 1.07, right? What's that?
Why is it 0.7?
Because you move the decimal over twice. You have to fill in that other blank with a 0.
So anytime it's a decimal is when you do 1 plus?
Anytime it's a percent. Anytime it's a percent. Yes. All right. So A says, write an exponential function that describes this situation. So we're going to say y equals. We begin with $360 billion. So we're going to say 360 times. And here's the thing. I'm going to leave it at 360 because if I wrote out billion, that would be a lot of zeros, right?
Yeah.
And actually, your calculator will give you scientific notation, which is not fun to do. So what we're going to do is we're going to leave it as 360, and in our answer, we know we're going to add that billion. Okay? All right, so then that's going to be times, what's my b value, Xavier? Look at your paper. What's our b value? We just wrote it down. 1.07. So times 1.07 to the x power. Because x is going to be the number of years that pass since 2005. What's that? Well, hold on. So in 2006, x would be 1. 2007, yes. So on part B, exactly. Part B says how much money was spent in 2011. That's 6 years later, right? So here we're going to replace x with 6. So I'm going to say y equals 360 times 1.07 to the 6th power. What do we get? 540.263. All right. So if we're talking about billions of dollars, though, do we care about a couple of million?
No. Yes.
No.
Yes.
I'm going to go ahead and round to the billions. I'm going to round to the billions for this problem. So we're going to say 540 billion.
Is it okay if I put my decimal?
Sure. Is that okay? Did you get the same thing? Oh, because you put all the zeros in. Oh, man. Whew. Marcus. Thank you, dear. All right, example 3. Last example. You ready?
That's nice.
I know. Robin already read it. Fantastic. Example 3 says Jody has an exterminator visit regularly to control an ongoing cockroach problem. Oh, I know. It's been working. Woohoo! And the population has declined by 5% every year. The population is currently 2,700 cockroaches. So, let's identify our a and b values to write an exponential function for Jody's problem.
Would it be 1 minus?
Yes! So let's do a first, and then let's talk about b with everybody, Robin, because you're exactly right. So a is 2,700, because that's how many cockroaches Jody starts out with, right? And then b, it says that the population is declining by 5%. So Robin said we're going to do what? Subtract. So it's going to be 1 minus 5? 0.05. Very good. 0.05. Which gives me what? 0.95. So then to write our exponential function, I'm going to say y equals 2,700 times 0.95 to the x power. So then on part B, Brandon, you said we're going to put 3 where? For the x. Perfect. So we're going to say y equals 2,700 times 0.95 to the 3rd power. So what does that give me? What is my y value?
2,314.91.
2,314?
Yeah.
You know what? Let's go ahead and round that up to 15 because we can't have part of a cockroach. So in 3 years, the cockroach population will only be 2,315. Yeah. So, in my opinion, that's not fast enough. I would get a different exterminator. But, I don't know. Maybe Jody's happy with it.
I'm not.
All right.